Okay, now we are going to talk about how to find the angles of right triangles. Last lesson, we talked about how to find the missing side of a right triangle when all you've been given is an angle and one other side. Now we're going to talk about how to find the missing angle when all you've been given is two sides. Okay? So, we're still going to be working with our trig ratios. You remember them from last lesson, sine, cosine, and tangent. But we're not going to be taking the regular sine, cosine, and tangent of these angles, of these triangles in order to find the sides. We're going to be using the sine, cosine, and tan inverse. Okay? So, if you remember, x is an angle. Okay? We've been using x as our variable for any random angle. So, in order to find angle x, okay, I'll just go ahead and do it for sine. X is equal to the sine inverse, that's what that -1 means, sine inverse of opposite over hypotenuse, okay? So, just like regular sine is opposite over hypotenuse, the sine inverse is opposite over hypotenuse, and that's how you would find the angle. Okay? So then, same thing for cosine. X will be equal to the cosine inverse of adjacent over hypotenuse, and x for tangent is equal to the tan inverse of opposite over adjacent. Okay, so let's work a couple examples out to kind of see how all of these work. So, first thing, we're going to create our right triangle. I'm going to call this side my A, my B, my C, and I'm going to use a Pythagorean triple, hint hint, 3, 4, and 5. Okay? So, say for example, I wanted to know what the measure of this angle was, right? I don't know what it is, but I want to solve for it. We know this angle right here is 90, but I want to know what angle C is. So I'm going to use my variable x for angle C. Okay? And so since I'm working with this angle, like always, we need to identify our opposite and adjacent and hypotenuse sides. That's hypotenuse right there. Alright, so since this is the angle that I'm working with, I draw my arrow to my opposite side. Then the angle directly next to it is my adjacent side. And my hypotenuse never changes. So, if I want to know what this angle is, I need to use, well, technically speaking, I can use any one of these trig ratios because I know what all the values are. But let's say I want to use the sine inverse, okay? So, if I want to know what this angle right here is, I'm going to use the sine inverse, which means I'm going to use the opposite and hypotenuse sides. So, in my calculator, but I'm going to set it up here first, I'm going to find the sine inverse. Okay, x is equal to, the sine inverse of the opposite side, 3, over the hypotenuse, which is 5. Okay? So, a couple things. When we grab our calculators, alright, I'm going to put this into the calculator. Now remember, you want your calculator to be in degree mode. Okay, so make sure it's in degree mode. And so normally the sine, cosine, tan buttons are right here. Your calculators might be a little bit different. But in order to get to that sine inverse or cosine or tan inverse, you hit second. Then you see the sine raised to the -1 power, or just the sine button. You get sine to the -1. Then I'm going to put 3 divided by 5. 3 divided by 5 in there. Press enter. Okay. And so I get the sine inverse of this is equal to 36.86, and I'm going to round that up to 87. So x, this angle x, is equal to 36.87 degrees. Okay? So that's how you find the measure of an angle. Okay? Let's do another example. All right. Switching colors here. So, different triangle, or similar triangle, rather. I'm still going to call this my A, this my B, and this my C. Went a little far there. Got my right angle box. And I'm going to call this side length 6 and this side length 8. Okay? And this is another Pythagorean triple, and if you think you know what the measure of side AC is, go ahead and try to figure that out. Pause the video. That's not part of the lesson, but it's good to know your Pythagorean triples. So, regardless, say for example I want to now work with angle A. Okay? I want to know what angle A is equal to. So I'm going to use this as my variable x. And since this is the angle that I'm working with, draw my arrow to find my opposite side. This is opposite. Okay? This is my adjacent side. Remember, the opposite and adjacent sides change based on the angle that we're working with. But the hypotenuse, always opposite that right angle box, never changes. Okay? So, I want to find the measure of angle x. All I've been given is the adjacent and the opposite side. What trig ratio uses opposite and adjacent? Opposite hypotenuse, tan inverse. So, in order to find x, x is equal to the tan inverse of opposite, which is 8, over adjacent, which is 6. Okay? So, plug this into our calculators. So hit second, and then the tan button. But if I hit second and the tan button, that'll give me tan inverse. 8 divided by 6. Okay. And I get 53.13. Okay, I don't need to round there, so I'm just going to be x equal to 53.13 degrees. Okay, and that's the measure of my x. So, a couple things to be sure of. Make sure that, just like the last example, what have you been given to work with? Here on this second example, I was given the adjacent and opposite side. So it means I had to use the tan inverse to find the angle. If all I had been given was the adjacent and the hypotenuse side, I would have used the cosine. And if all I had been given was the opposite and hypotenuse side, I would have used the sine inverse. Okay? But because I was only given adjacent and opposite, I used the tan inverse. So remember that when you're trying to find a side, you're just trying to use regular sine, regular cosine, regular tangent. But when you're trying to find the sine, or excuse me, the measure of an angle, you use sine, cosine, or tan inverse, that -1 exponent. All right? And that's it.